Right, that was that about 1.1.2. Now we are indulging 1.1.3. In 1.1.3, this is what we have. In 1.1.3, we have what is called quadratic inequality. Remember also, when we solve quadratic inequality, it must be in the standard form of ax square plus bx plus c, then greater or equal to 0. Already we have a term with the square as the first term, we have a term with an x as the second term, then the last term it should be a constant number. Now in this case we have negative 2x squared plus 3x. Now we need to have a constant term. We need to take this negative 2 from this side of the equation, transpose it to this side, so that we have the standard form of a quadratic inequality. Since, well, it has a negative number, which is negative 2, when we transpose it to this side, we can't retain the same sign. The sign needs to change. Therefore, when we transpose, we have a plus 2 that is greater than or equal to 0. Now, before you even do anything to this quadratic inequality, the one that we have here, you need to understand what solutions of x are you looking for here. We are looking for all values of x, such that when we put them in the place of an x, we only get numbers that are 0 and numbers that are only positive. I'll repeat my statement. We are looking for all. We are not looking for 2, we are not looking for 1, we are not looking for 3. We are looking for all values of x. Says that when we plug them where we see an x there, the only solution that we need to get when we punch that into our calculator, we need to get solutions such as what? 0 and only positive numbers, because the inequality says greater than or equal to 0. Therefore, those solutions of x must give us what? 0 and numbers that are positive only. Now, since well we have a standard form of a quadratic, we need to write the word CV. CV, it indicates that we are looking for what is called the critical values. Why are we looking for the critical values? Because in this regard we are actually having a quadratic inequality. That's why it is of importance that we write the word CV to indicate that the step that we are undertaking is the step to allow us to have what is called the critical values. Then in order to have our critical values, we are going to apply our quadratic formula, which says x is equal to negative b plus and minus the square root of b squared minus 4 ac, then everything divided by 2a. Then x is equal to, then the value of b that we have here, it will be the value of b and its respective sign. The value of a that we have here is the value of a. The value of c that we have here is the value of c. Now we need to just substitute negative that came with the formula. The value of b that we have here, it is a positive 3 plus and minus the square root. Remember, when you substitute the value of b outside, please, when you substitute inside the square root, put brackets there to say positive 3 close bracket all square minus 4. Then the value of a that we have here, it is and its respective sign. In this case is negative 2 close bracket open bracket. Then the value of c that we have here it is to be positive 2 close bracket. Then everything else divided by 2 multiplied by the value of a. In this case the value of a is negative 2. close bracket. Then the first critical value x will be equals to the second critical value x, it will be equals to. Now we use our calculator. Fraction -3 plus square root 3 all squared minus 4 open bracket -2 +2, then 2 multiplied by -2. The first critical value that we have is x equals to -1/2, which is our smallest critical value, -1/2, which is half, -half. The second critical value, it is x equals to 2. Then this will be the first solution of x, which is the first critical value. Then the second solution of x, which is our second critical value, x, it will be equal to +2. X is equal to +2. That is our second critical value. Now, these are not the solutions of x. I want to emphasize, these are not the solutions of x that we are looking for. These are called the critical value, which are going to help us to find the real solutions of what? Of x. Now, after you have got the critical values, then what needs to happen? You need to go to the number line. The number line is the graphical representation that we often use to help us to find those real solutions of this quadratic inequality that we have here. Now we go to the number line, we draw our number line, here it is. Then we start with the smallest critical value. Then the smallest that we have here, it is the one with the negative. Then we are going to have -1/2. Then we have the bigger critical value on this side. In this case, is +2. Now, we need to indicate if we are going to shade the critical value or not shade the critical value. Then, what is an indication if we are going to shade the critical value? You need to go back to check if your inequality sign, it has a bar. In this case, our inequality is greater or equal to. Therefore, this part of the inequality, I call it a bar. Therefore, if the inequality sign, it has that bottom part which is called a bar, we need to shade the critical values. Then we go there to shade. We shade the critical values. And also here we shade the critical values. Let us shade here so that everything is clear. How do you shade? How do you know that you are going to shade? If the critical value, it has this bottom part which is equal to, for me, I call it a bar. If it has that bar, it means you need to shade the critical value on the number line. Now, we go and check here. If the coefficient of x squared term, it has a negative sign, the one that we have here, it has a negative sign. Now you have done what is called the graphs. Since now we are having a quadratic inequality here, we know we are going to use a parabola here. Since we have a coefficient of x squared term that has a negative sign, we are not going to have a parabola that is faced upwards. But because of that negative sign, which is the coefficient of x squared term, we are going to draw a parabola that is facing downwards. If the coefficient of x squared, it has a positive number or a positive sign, then we are going to draw a parabola that is facing upwards. But the one that we have here, remember we have the coefficient of x squared term here that has a negative sign. Here it is. The x squared term is coefficient, it has a negative. Then we draw a parabola that is facing upwards. That is facing downwards, like the one that I have here. Now, we need to go and shade the correct region of the parabola. Then, as far as the shading is concerned, how do you know as to where you are going to shade? You go to the inequality. The inequality, it says greater. This is the greater inequality. It says greater. The word greater means bigger. The word bigger means positive. I'll repeat. The inequality, if it is facing this direction from all the terms, if it's facing this direction, this inequality, it is called greater inequality. The word greater means bigger. The word bigger means larger. The word larger means a positive. Then we are going to shade a region of this parabola that is what? Positive. The only region that is positive is the region of the parabola that is above our number line. Remember, this is our number line. Then we need to go and shade the region here that is above the number line. And we have that region. Here is the region. This region here, it lies above. It is a region that is what? Above the number line. Therefore, we must go and shade that region. Then you can't shade on this direction. You can't shade on this right. Remember, this region is here. It's like a concave. Then how do we shade that region? We are going to shade here below. Below what? This region here. It means this is where our solutions of x lies. Now, I always say, if you have shaded once in the correct region, like I have done here, one shading, it means you must have only one x. If you have shaded twice, you must have two x's. I have shaded once, I put an x here. I put an x here. Now, whatever in a critical value that I have here, I bring it down. Here it is, negative 1 over 2. Whatever in a critical value that I have here, I bring it down. Here it is. Now, from negative 1 over 2, I've shaded this direction. Then which numbers are on this direction? We are speaking of number like 0. We are speaking of number like 1. We are speaking of number like 1 over 2. Here. Then we want to decide if this number 0, 1, 1 over 2, are they larger or smaller than negative 1 over 2? We know that 0, it is greater than negative 1 over 2. We know that 1, it is greater than negative 1 over 2. We know that 1 over 2, it is greater than 1 over 2. Therefore, x, it must be greater than or equal to negative 1 over 2. Then we come on this critical value. We are facing this direction. We have shaded on this direction. This direction going here. Then we have numbers like 1 over 2. We have numbers like 1, 0, negative 1 over 2. Are these numbers greater than, bigger than 2, or are these numbers smaller than 2? We understand that 1 over 2, it is small. 1, it is smaller than 2. 0 is smaller than 2. Then x, it must be smaller than or equal to a positive 2. Therefore, this will be a final solution that we are looking for this quadratic inequality. Then mark allocation there. Let us see. Mark allocation there, it will be 3 marks. How do we award 3 marks there? 1 mark for the critical values. 1 mark for x must be greater than negative 1 over 2. 1 mark for x must be less than 1 over 2. That is that. That is that. Now that is all about 1.1.3. Then we are going to head straight to 1.2. In 1.2, it says solve for x and y simultaneously if we have 2x plus y, that is equal to 3, and 2y plus 2x squared minus 5, that is equal to negative x. This is a simultaneous equation that we have, and we know by now that simultaneous equation, it always consists of 2 distinctive equations. The word distinctive means 2 different equations. Then here we have a linear equation, and here we have a quadratic equation. That's why they are distinctive.